Right, today we're going to be talking about the Pythagorean Theorem, and this should be a review for most of you. Let's start out by looking at a right triangle, because a right triangle is the shape that the Pythagorean Theorem is used for. So a right triangle, what's good to know is that there's a couple key vocab words here, and I have a picture for you. The hypotenuse, it's always the side that's opposite the right angle in a right triangle, and it's always the longest side. So those two things are always true about a hypotenuse. Opposite the right angle and the longest side. The legs, they are each of the sides that form the right angle in a right triangle. So they touch the right angle. Those are called the legs. Okay. The Pythagorean theorem, you spent a long time developing how this works last year. So we're going to just shortcut it up right now. The Pythagorean theorem says that a squared plus b squared equals c squared. This is only true in a right triangle. And if C stands for the hypotenuse, and A and B are the legs. So leg squared plus leg squared equals hypotenuse squared, and that's only true in a right triangle. Okay, so I want you to use the Pythagorean theorem to find the length of hypotenuse of this triangle. And since you practiced it so much last year, try to do it before I even solve it. But if you forget, you can follow along with me. Okay, so we're going to start out, these are both legs, and I know I'm going to use a squared plus b squared equals c squared, and a and b are both my legs. So in this case, I'm going to do 8 squared plus 15 squared, and that should equal c, or the hypotenuse squared. 8 squared is 64, 15 squared is 225, that's still going to equal c squared. 264 plus 225 is 289, so 289 equals c squared. So I want you to take the square root of 289. So we're taking the square root of 289. And notice I only wrote the symbol for the positive square root symbol because it's a distant, so it's not going to be a negative number. And that happens to be 17. So C is 17. And it's going to be in the same measurement. It's going to be 17 meters is the length of my hypotenuse. Okay, let's look at a problem that's a little bit more complicated, but looking at the same general idea. Okay, so this is a good one here. All right, a toy fire truck is positioned so that the base of the ladder is 13 centimeters from the wall. The ladder is extended 28 centimeters up to the wall. So there's the ladder. We got our 28 centimeters in there. I'll highlight that measurement. Okay, so right here, that's this ladder. Okay. And I want to know how high above the tabletop is the top of the ladder. So what I'm looking for is how far it is from the top of the ladder to the tabletop. So I'm looking for that entire distance. Okay, but you're going to notice that I just have a right triangle right here. And 28 centimeters is my hypotenuse. So I know that in this case, if a squared plus b squared equals c squared, this time I know what a is, it's 13 squared. I don't know what b is, and I do know what c is. Okay, so I'm going to start solving these. I know that 13 squared is 169, plus I don't know what b squared is yet. 28 squared is 784. Okay, so if we're solving this like a normal algebraic equation, I'm going to start subtracting 169 from both sides so that I can get b squared alone. And once I do that, I get that b squared equals 615. Okay, and remember, I'm going to take the square root of 615 to get that b is approximately 24.8 centimeters. Okay, but look closely. This question asks how high above the tabletop is the top of the ladder. So B right here, 24.8 centimeters, is not the entire height. There's also this 9 here. So I'm going to add 24.8 and 9. And I'm going to get about 33.8 centimeters. And it's important to note that we have this little approximately symbol in the front because I rounded. I should actually probably put it inside the circle. So I rounded, so I want to show that. Okay, so those are two ways you could use the Pythagorean theorem to find a missing leg or a missing hypotenuse. We're going to move on to some of the lesson, a part that's new for you, that you probably haven't talked about much, or if any, in the past. Okay, so let's look at some vocab. Okay, we're going to look at a conditional. A conditional is an if-then statement. So here's like a normal word one. If it is raining outside, then I wear a raincoat. Okay, it has an if part and a then part. It's a conditional. If it is raining outside, then I wear a raincoat. In math, we consider the hypothesis the if part of the conditional. So the hypothesis in this case, let me do some color coding for you. The hypothesis in this case is the if part. So it is raining outside. That's the hypothesis. It's raining outside, the if part of the conditional. The conclusion is the then part of the conditional. So in this case, the conclusion is I wear a raincoat. Okay, so hypothesis, it is raining outside. Conclusion, I wear a raincoat. Okay, that's for the conditional both parts. The converse of a conditional, it switches the hypothesis and the conclusion. Okay, so it switches the if and the then. So let me just go ahead, let me do a little bit of typing here and see if I can squeeze it in. So in this case, if I was going to put the converse of this one, I'm switching the if and the then. So I'd have if I wear a raincoat, then it is raining outside. Okay, so that is my converse this time. If I wear a raincoat, then it's raining outside. And it's important to note that a converse may or may not be true. And I want to just talk about when it may be true and when it not be, or when it would not be. And we'll look at that in just a second. Okay, we're going to look at a few statements, and I want you to try to come up with the converse of the statement and think if it's true or not. So this first one says, if you are in this advanced algebra class, then you are in 8th grade. So we know that the if statement, the hypothesis, is you are in this advanced algebra class. Okay, and the conclusion is you are in 8th grade. That is a true statement. If you are in my advanced algebra class, you are in 8th grade. Okay, did you try to come up with a converse yet? Okay, the converse, we're switching them. So it says, if you are in 8th grade, you're in an 8th grade, that was my conclusion, then you are in this advanced algebra class. Okay, if you know much about our school system, that is definitely a false statement. Okay, so this is false. So originally I came with a true statement, and its converse was false. Okay, let's look at a couple math ones and see if you can get this. So here, if a shape is a square, then it is a rectangle. Okay, that's definitely true. Let's look at the converse of that. Okay, so we're switching the if and the then. If a shape is a rectangle, then it is a square. Well, I can think of some rectangles that aren't squares, like this one. Okay, so this original statement, again, was true, but the converse was false. Okay. Here's another one. If an angle is 90 degrees, then it is a right angle. If an angle is 90 degrees, then it is a right angle. Okay, that's a true statement. Okay, now we're going to flip it. It's the converse. If an angle is a right angle, then it is 90 degrees. That's also a true statement. So in this case, my original was true, and my converse was also true. So sometimes when you flip a statement, it's still true. Sometimes it's not, though. So I would just want you to keep that in mind. Okay, the converse of the Pythagorean theorem. So you should know that the Pythagorean theorem basically says if, oops, it's an I, ha. If a triangle is a right triangle, then a squared plus b squared equals c squared. It's basically what the Pythagorean theorem says. If a triangle is a right triangle, then a squared plus b squared equals c squared. Okay, so the converse of the Pythagorean theorem would say this. If a squared plus b squared equals c squared, then the triangle is a right triangle. So I put a lot more words here, but here's the most important parts. So if a squared plus b squared equals c squared, then triangle is a right triangle. So if a triangle has side lengths of a, b, and c, and a squared plus b squared equals c squared, then the triangle is a right triangle with hypotenuse of length c. This is the converse of the Pythagorean theorem. Last year you probably went outside with some ropes or something and tried to see if this worked, and you found out with the conclusion the converse of the Pythagorean theorem is always true. So if we see a squared plus b squared equals c squared, then we know with confidence that that's going to be a right triangle. So let's try to solve a couple of problems here and see what happens. So basically I'm looking for, does a squared plus b squared really equal c squared? So would these side lengths be the side lengths of a right triangle? So 5 inches, 5 inches, and 7 inches. If this were to be a right triangle, 7 would have to be my hypotenuse because it's the largest side. So I am just going to check here if 5 squared plus 5 squared really does equal 7 squared, or if it doesn't. So 5 squared plus 5 squared, that's 25 plus 25. 7 squared is 49. And 25 plus 25 is 50, which does not equal 49. So because a squared plus b squared does not equal c squared, we can say this is not a right triangle. Okay, so it's not. All right, this one, 10, 24, and 26. So I'm going to do the same process here. The 26 is the longest one, so if this is a right triangle, that's the one that would be C. So we're going to see if 10 squared plus 24 squared really equals 26 squared. You should be trying this one on your own. Okay, so 10 squared is 100. 24 squared is 576. 26 squared is 676. So in this case, I get that 676 equals 676. That is true. A squared plus b squared does equal c squared, so yes, this could be a right triangle. Okay. So you should be able to distinguish just by playing with the side lengths whether or not you've got a right triangle there. Okay. Let's look at some physics. Mr. Brightbill will love this problem. So we've got two forces pulling at each other. Okay. Force A is pulling in this direction, just directly, we'll say east, with a 50-pound force. And then force B is pulling south with a 120-pound force. Okay? And then you get this resultant force coming this direction that's 130 pounds. And what we want to know is, are the forces pulling at right angles to each other? Okay? So what happens, same kind of thing here, if they are pulling at right angles to each other, then force A squared plus force B squared should equal force C squared. So if it does, they're at right angles to each other, and if not, they aren't. So we want to check, is 50 squared plus 120 squared really equal to 130 squared? Okay, so that's what we're checking, and if it is, we're probably good. And if it's not, we're probably not good. So 50 squared is 2,500 plus 14,400. And we want to know, does this equal 16,900, which is 130 squared? So, well, lo and behold, that does equal 16,900. So because a squared plus b squared really does equal c squared, yes, they are pulling at right angles toward each other. Okay, think about this as you're wrapping up. So how can you determine which side of a right triangle is the hypotenuse? Okay, what two key things can happen there? And what is the Pythagorean theorem used for? I would love it if you could think not only what shape is it used for, but what might be some practical applications in real life for that. Come back tomorrow and tell me, and you'll get a chip. Or Monday, whatever day this may be. Okay, talk to you later. Bye.